So we are starting algebraic vectors today, and we are doing 6.5 vectors in R2 and R3. So in R2 and R3, the location of every point is unique. When we say R2, we are talking about 2D system, x-axis and y-axis. When we say R3, it is written as R cube, but when you say it, if you say R3, it involves three axes, x, y, and z axis. So it is the 3D vectors, okay? So we're going to represent 3D vectors in R3 system. In R2 and R3, the location of every point is unique. As a result, every vector drawn with its tail at the origin and its head at the point is also unique. This type of vector is called a position vector. Position vector. If the tail is at the origin. In R2, point AB is a point that is A units from the origin along x-axis and B units parallel to y-axis. The position vector OP has its tail located at 0, 0 and its head at point AB. So OP vector is also shown as AB, like point AB. So let's say we have a point P here. The coordinates are A and B. So how you locate that point? So you start from the origin, you go along x-axis A units, then you go parallel to y-axis B unit, and then locate that point. And if you draw a vector putting the tail at the origin and the head at the point, okay, then you get OP vector. And since the tail is at origin, this vector is called position vector. So when you write, let's say you have a point 2 and 3, okay, well, in this case, it's kind of, doesn't matter. You can, let's use other numbers, 4 and 5. Okay, let's say you have point 4 and 5. So you can draw a vector putting the tail at the origin to get OP vector. And we also say that that OP vector has coordinates 4 and 5. So don't get confused with these two because we kind of use the same notation, except this is saying that this is a point, and this one is saying that this is a vector. So points and vectors in R3. In R3, point ABC, so this time we have 3 coordinates, x coordinate, y coordinate, and z coordinate, is a point that is A units from the origin along x-axis, B units parallel to the y-axis, and C units parallel to the z-axis. That's how you locate a point in 3D system. Okay, so first you go A units on x, then you go B units parallel to y-axis, and then you go C units parallel to z-axis. Okay. The position vector OP, so similar to 2D, also can be represented with A, B, and C. So this is point ABC. This is OP vector, position vector ABC. Has its tail located at origin and head at this given point. Okay. So Xyz Z system, to show it, we use right hand method. Okay, so you take your right hand and then make 90-degree with your 3 fingers, and the thumb pointing up is your z-axis. The one that's sticking out is your x-axis, and the one pointing here is your y-axis. So these are positive z, x, and y-axis. So if the one that's pointing up is z, then the one that's pointing down is going to be negative z. So this one is positive x, and the one that is coming to the other side is negative x. This is positive y, and then there is negative y on the other side. I also use this one cut from a box. Okay, so as you see, all those three x's make 90 degrees with each other. So this one is sticking up is z-axis, x-axis, and y-axis. Let's say you want to locate a point on this 3D system. Let's say the coordinates of that point is 2, 3, 4. Okay, so x coordinate is 2. So starting from origin, this is the origin, you go 2 units on the x-axis. So y coordinate is 3. So you go parallel to y-axis 3 units. And then z coordinate is 4. So you go parallel to z-axis going up 4 units and then locate the point. So, and if you draw a vector, so this is, let's say, your point, and then you start from the origin. So let's say this is the tail, and then you draw a vector to the point P. So that vector is a 3D vector. Again, the tail is at the origin, and then the head is at the point. And that's called a standard vector again. The XZ plane is determined by X and Z axis. So I'm going to use a piece of paper here. So to show you what XZ plane is. So this is the X axis, that is the Z axis. The plane that holds these two axes is XZ plane. And that plane is considered going all directions to positive infinity and negative infinity. Maybe I could have used a smaller paper. Okay, so again, XZ plane is this plane. Okay, so a YZ plane, so this time we use y-axis and z-axis. The plane that holds those is going to be this plane. And the other one is xy plane, is determined by x and y-axis, x-axis, y-axis. The plane that holds that, the piece, this is the piece of paper, right, representing that plane, okay, in going all direction, positive infinity, negative infinity, positive infinity, and negative infinity. So that plane is called xy plane. So again, planes extend infinitely far in both the positive and negative directions. So now we are going to look at some examples. Okay, so in the following diagram, the point 6 to 4 in 3 given. So what are the coordinates of A, B, C, D, E, and F point? Okay, that's what we're going to look at. So this again, so 6 to 4. So that is the x-axis. So of course now, you see x, y, and z axis here. And 3D system is drawn on 2D. Therefore, when you look at these, so they may not look like 90 degree, but you should know that there is 90 degree between all those axes here. Okay, but again, it is drawn in 2D, therefore it may not look like 90. So this point, how it is drawn, so it's 6 units you go on the x-axis, then you go 2 units parallel to y-axis, and then you go 4 units parallel to z-axis. So that is the point P. So we draw kind of a rectangular prism to represent that point. If we don't draw that rectangular prism, actually the location of that point is not clear. The coordinates is not clear. Therefore, we kind of draw rectangular prism to show its location clearly. All right. So based on that, what can we say about point A? Point A is on x-axis. So you go 6 units on the x-axis and you find point A. Okay. So therefore, x coordinate is 6, but y and z coordinates are 0. So let's remember 2D system. If you have an x-intercept, let's say 3, then your y coordinate is 0 for that. Or if you have a y-intercept of 5, then your x coordinate is 0, so 0, 5. So similarly, if you have a point on the x-axis in 3D system, y and z coordinates are 0. Or if you have a point on y-axis, then x and z coordinates are 0. If you have a point on z-axis, x and y coordinates are 0. Okay, so that is 6, 0, 0. So let's look at point B. So you go 6 units on x-axis and 2 units parallel to y-axis. So we don't go up or down. So z coordinate is 0. So then point B is 6 for the x, 2 for y, and nothing on z, which is 0. So let's look at C. To go C from the origin, you go 6 units on x-axis, and then you go 4 units up parallel to z-axis. So we don't go right or left. Therefore, y coordinate is 0. So again, for C, we have 6, 0, and z coordinate is 4. So let's look at D. Point D is located on z-axis. So therefore, again, x and y coordinates are going to be 0. So z coordinate of that point is 4. So 4 units up. So therefore, z coordinate is 4. So let's look at E. Point E. So if you start from the origin, we don't go like here or to the back. So it looks like x coordinate is 0. Okay, but to reach that point E, you go 2 units on y-axis and you go 4 units parallel to z. So nothing on x, 2 units on y, and 4 units on z-axis. So point F is located on y-axis. So we know that x coordinate and z coordinates are 0. And y coordinate, again, using this point, so 2 units on the y-axis. So this is the EF. Yes, that's it. Okay. And as you see, the point P is here, right? 6, 2, and 4. So draw vector OP. So we start from the origin and then draw this vector here. Head at point P. Okay, so let's look at example 2. In the following diagram, the point T is -3 to -2, is located in R3. What are the coordinates of P, Q, R, M, N, and S. Okay, so let's start with P. Okay, so it is on y-axis. We expect X and Z to be 0. So now look at the point T, because that box, rectangular box, is drawn for this point. So it means that the y is 2. So that point is on the edge of this box. So the y coordinate is 2. So Q is here. So we go to reach point Q from the origin. We go 2 units on y-axis, and then we go down, so -2 down. So CZ, positive Z is pointing up, and negative Z is pointing down. So -2 is here. So then coordinates of that point Q. So for x-axis, we didn't go this direction or that direction, anything. The positive x and negative x, we didn't go. So x coordinate is 0. So y coordinate is 2, and then 2 units down, -2. Let's look at point R. So to reach that point, again, it is actually on the z-axis. Okay, so this is positive z, and the one that is going down is negative z, right? Okay, so that point R then is on the z-axis. So the x and y coordinates are 0, and z coordinate is -2. That is point R. Now M, so to reach M from origin, as you see, you only go along x-axis, so that is positive x, obviously that is negative x going that direction, and that point then must be -3, and it is on x-axis. Y and z coordinates are 0. Point N, to reach point N, you go M units on x-axis, nothing on y-axis, and you go down, which is the z-axis, parallel to z-axis, 2 units. Okay, so x is -3, nothing on y-axis, and then you got -2 on z. And point S here, so you go on x-axis 3 units, but to the back, so -3, and then parallel to y-axis 2 units, so -3 and 2, nothing on z-axis. And then finally it asks for OT vector OT. You start from the origin, you go to the point T, and that is the vector. Let's look at example 3. So this, a point Q is given in R3. So here is a point Q. Coordinates are 2, -3, -5. So this is the origin, and then 2 units on x-axis, -3 on y-axis, so that is positive y, that side is negative y, so -3 on y-axis, and then -5 on z-axis, so you go down, -5. So this is point Q. It says write an equation for xy plane. So x is here, y is here, so we are talking about this plane. Again, I showed you before. So z, x, y, xy plane it is the plane that holds x and y axis. So we are talking about this plane. When you look at this plane, all the points on that x and y xy plane will have a 0 for z coordinate. Okay, so because any point on that plane, so to draw that point, you don't go up or down, which is the z-axis in this case. Okay, so all the z coordinates are 0 on that plane. Therefore, xy plane can be represented as also z equals 0 plane. That means, again, all the points on that xy plane will have coordinates xy and 0 for z. B, write an equation for the plane containing the points PM, QT. PM, QT. So we are talking about a plane that holds these 4 points. Okay, so but think that we are talking about now the plane uh, that covers those 4 points. So it goes infinity all that on all directions. So how can we write the equation of that plane? So now let's pay attention to the coordinates of those 4 points. Okay, PM, QT. So 0, -3, 0, 2, -3, 0, 2, -3, -5, and 0, -3, -5. So now check for the something common. Okay, so when we look at those 4 points, we see that the y coordinates, all of them have y coordinates of -3. Okay, so this means that if I have a point on that plane, any point, those points will have coordinates of x, -3, z. Okay, so what is common? Y coordinate is always -3. Therefore, we say that plane, the equation of that plane is y equals -3. Write a mathematical description of the set of points in the rectangle PMQT. So now we are only looking for this PMQT. Okay, so if you look at the x coordinates of those points, only we are looking at this rectangle here. Okay, so look at the x coordinates 0, 2, 2, 0. So if you have any other point on this plane, all the so those x coordinates of those points will be between 0 and 2. Okay, so that is one condition, right? X coordinates will be between 0 and 2. Oh, so x coordinates are between 0 and 2. So y coordinates, so -3, -3, -3, -3. Again, all of them have y coordinates -3. And let's look at z coordinates now. So z coordinates 0, 0, -5, and -5. So all the z coordinates are between 0 and -5. Again, if you pick any point on that plane, that point must have a z coordinate between 0 and -5. So z coordinate is between 0 and -5. So these 3 conditions represent the set of points on that rectangle, PMQT. The last one, what is the equation of plane parallel to xy plane and passing through 0, 0, -5? Okay, so you are going to write an equation of a plane which is parallel to this xy plane. It's going to be parallel to this xy plane, but it's going to pass through 0.00 -5. The z coordinate is -5. You can see it, but underneath this, right? So somewhere here on the z-axis, you will have 0, 0, -5. You're going to find a plane actually that is passing through that 0, 0, -5, but parallel to xy axis, xy plane here. So how can you write the equation of that plane? Okay. Well, on that plane, now you will see that z coordinates are going to be always -5. Okay, so therefore that plane is called z equals -5, and x and y can be anything else. Okay, so we're going to look at example 4 as last. We're going to plot this point, but as we do that, we need a ruler. Okay, I'll give you a minute, and I ask you to find a ruler. Okay, and we will do in a minute. Is your ruler ready? All right. Yes? Okay, excellent. All right. So we're going to plot point A, coordinates 3, 2, 4. So we go 3 units on x-axis, 2 units parallel to y-axis. Okay. To build a rectangular prism like this is what we are going to do. So we are going to go 3 units on here, 2 units parallel to y-axis. To be able to do a precise box, I'm just going to measure here, okay, from origin to 2 units on y-axis. So for me, it is like 1.2 centimeters. So I'll go 1.2 centimeters from 3. Okay, and then you will draw a line from here. So it looks like a parallelogram. Actually, it is a rectangle, don't forget, right? So this is a 90-degree, but because, again, you are drawing something 3D in 2D, so it doesn't look like 90, but actually it is a 90-degree here. So, but you will kind of, it looks like a parallelogram here. So the next thing we are going to do, we're going to go parallel to z-axis 4 units. So 4 units here on the z-axis. I'm going to measure from, again, origin. So that gives me 2.4 centimeters. Okay, 2.4 centimeter. So I'm going to go 2.4 centimeter from all the corners of this rectangle. Looks like a parallelogram. So I go up 2.4. So that is already 4. So I'm going to go from this corner, 2.4. And 2.4 from here. Okay, and the one, of course, point is there. So now again, join those points. So you will see it as a parallelogram, but it is another rectangle, as a matter of fact. Okay. Um, I didn't do a good job here. Let me fix it. Yes. Okay, so that's the box. So then what is point, where is point A? So 3 units on x-axis, 2 units parallel to y, and 4 units parallel to z. So this point is point A. Okay, now let's look at point B, 104. So 1 unit on x-axis, nothing on y-axis, but 4 units parallel to z. If you go 4 units up, actually that is on the edge of this box that you built. That is point B. So let's look at point C, 0, 3, 4. 0 on x-axis, 3 units on y, 4 units parallel to z. We don't need to build a box here because it has only 2 coordinates. So that is, I mean, the one coordinate is 0. So that is point C. Y is 3, Z is 4. So it is on it is on YZ plane. And it says determine the equation of the plane containing the points A, B, C. So A, B, and C. We are looking at the plane that contains those 3 points. So what is common about those 3 points? So when you look at it, you also kind of see from here too. The Z coordinate is always 4. Therefore, the plane containing those 3 points, Z equals 4 plane.